This is question 6 on your practice final concerning the sample mean. And it talks about a lake full of fish, and the mean of all the fish in the lake, the mean length, is 8 inches. So we say mu, the population mean, is 8 inches. So if you average the lengths of all the fish in the lake, 8 is the number you get. Then they say sigma, the population standard deviation, is 2.25 inches. And the lengths of the fish are normally distributed. So therefore, we could draw a normal curve to represent the distribution. Let's say x is the length of one fish pulled out of the lake at random. Well, 8 is the mean, and the standard deviation is 2.25. So I can put these numbers underneath. These inflection points, the left inflection point is 1 sigma below mu, the right inflection point is 1 sigma above mu. Inflection points are where the curve changes from being curved downward to curved upward. So we say x is normally distributed. X is the length of one fish that's taken out at random from the lake. Now, question 6 on your practice final talks about taking a sample of fish. So instead of one fish taken out of the lake at random, we're going to start by taking 15 fish at random. Now, let's assume we're going to take 15 fish at random and take the mean of their lengths. Well, when we do that, we get x bar. Notice how it's taller and thinner when we go to a sample. And the mean stays the same, because we remember from our fun facts about x bar, mu sub x bar is the same as mu. So the mean is the same. However, the standard deviation of the sample mean shrinks, and it's sigma over the square root of n. And if you know n is 15 and sigma is 2.25, then sigma sub x bar is 0.6. So this is what the curve looks like. Now, we know that x bar has a normal distribution because x is normally distributed. That's another one of the fun facts. If x is normal, x bar is normal. Now here's the question. What's the probability that a random sample of 15 fish has a mean length greater than 10 inches? So this is what I want to find out. Well, here's what I do. I take this x bar value and turn it into a z-score. Using the formula, z equals x bar minus mu over sigma over root n. So it's 10 minus 8 in the numerator and 2.25 over the square root of 15 in the denominator. And when you do that, you get 2 over 0.6, which is about 3.33 for z. Okay? So you turn that number into a z-score. And that formula can be found on the back of the first page under Chapter 8 on the left side, right under the words Chapter 8. The standardized version of the variable x bar. That's what z is. Okay, so now I have my z-score, and what I can do is go to Table 2, and here's what I want. I want the probability that z is greater than or equal to 3.33. Well, Table 2 gives me the area less than that. So I go 1 minus the area less than 3.33, which I can find from Table 2. And if I do that, I'll find that the area to the left of 3.33 is 0.9996. And so the answer is 0.0004. That's the probability that if I take a random sample of 15 fish, the mean length of that sample is greater than 10 inches. Again, I converted that 10 inches to a z-score of 3.33. Now the next question was, what if instead of 15 fish, we took a sample of 50 fish? So now n is 50. And we want the probability that x bar is greater than or equal to 10 inches for n equals 50. Well, I do the same thing as before, except I change the value of n. Z is now x bar minus mu over sigma over root n. And so this is going to be 10 minus 8 over 2.25 over the square root of 50. However, that's going to be much, much bigger than before. In fact, it's over 6. Let's say it's over 6.5. So it's well over 6.5. So in other words, what I want is the probability that z is greater than 6.5. So that's going to be 1 minus the probability z is less than 6.5. Well, 6.5 is off the charts. If you go to Table 2, 6.5 is off the charts. So the probability for a z-score off the chart positive is 1. So the answer is 1 minus 1, which is 0. So there's 0 probability that a random sample of 50 fish has a mean length greater than 10 inches. Now, one last thing. Remember I said if x is normal, x bar is normal. Well, there's one other fun fact you need to know, and that is if n is more than 30, then x bar is normal no matter what the shape of x is. So even if x is, say, uniform, a not normal distribution, if n is more than or equal or more to 30, then x bar is going to be a normal curve. and you can use table 2. So that concludes question 6.